Okay, question 25. It says here, region R is bounded by the curve y equals sine x, the x-axis, and the line x equals pi over 4. Find the volume of revolution. Right, now the volume will equal, of course, the integral from 0 to pi over 4. Okay, now I say 0 to pi over 4. It doesn't say 0 here, but it says it's bounded by the curve sine x and the x-axis and the line y equals pi over 4. Now I know what sine x looks like, and it starts like this, doesn't it? Okay, and pi over 4 is 45 degrees, so we've got that's about pi over 4 there. Okay, so that's the upper limit. Now the lower limit's got to be 0, isn't it? So you have this region here that's bounded, so the lower limit is 0. Then of course pi y squared, so you can put the pi out here, and y squared, then you've got to square this, so it'll be sine squared x. Now in order to integrate sine squared x, okay, you've got to use the double angle rules. Okay, you've got to replace this with cos 2x, right, or an arrangement of cos 2x based on the rules that we learn. Okay, in order to establish the rules, you must remember the thing from C2, sine squared x plus cos squared x equals 1, right? That's really important that you remember that. And then with the rules then, think about the double angles cos 2x, and if you go through the formula booklet to derive it, right, you end up with the first one, which is cos squared x minus sine squared x. Okay, but you might remember that for the exam, which is great. Okay, but here I want to replace cos 2x with sine squared x, and you don't want to have a combination, right, of both of them. You just want to have sine squared x, so we've got to get rid of cos squared x, so we can get another result which you might have learnt. Cos squared x you can get from here. So if you think about it, take that sine squared x over, so you from this rule, so take the sine squared x over, and cos squared x will be 1 minus sine squared x. That's what cos squared x becomes. Take away then another sine squared x, so you get 1 minus 2 sine squared x. Okay, that's what cos 2x is. What we'll do then is we'll rearrange this to get it in terms of, take a sine squared x in terms of everything else. So take that over the other side, 2 sine squared x will be 1 minus cos 2x. And then sine squared x then, we'll take the 2 over and divide it, so it'll be half. Okay, so you get this here. So that's what we replace it by. Now, the volume then becomes pi, between 0 and pi by 4, of this here, half 1 minus cos 2x. Okay, now because half is a constant multiplier here, take that out, so pi over 2. 1 then minus cos 2x in here, which we can easily integrate. Okay, so we're going to integrate, square brackets, 1 then becomes x when you integrate it, cos 2x when you integrate it, well, cos becomes positive sine, right? So because there's a minus there, it'll be minus sine 2x. Of course, then you've got to divide by the number there, which is 2, between pi by 4 and 0. So okay, so then chucking them in. Okay, pi by 4, take away sine 2 pi by 4 over 2, minus then pi by 2, 0, take away sine 2 of 0 over 2. Now I know, obviously that's 0, but I know sine 0, to check in your calculator, is also 0, so all of this will just go, right? This is 2 times pi over 4, right? So that becomes pi by 4, sine, actually that's pi over 2, okay? And sine pi over 2, you can check on your calculator, obviously it's got to be in radian mode, right? Is just 90, that's 90 degrees anyway, but sine pi over 2, right, is 1, right? So you end up with this as our answer, right? So you can leave it like that, or you can put it in decimal form, right? It's up to you how you leave it in. Sometimes they say 3 decimal places, you need to get it in 3 dp.